Welcome to Mechatronics. I really like this course. I've taught it for several years now. It was a course that I developed along with Professor Henry Zhang on main campus, and it's an area that's near and dear to my heart. I studied robotics and automation for my master's degree at Purdue and really enjoy this topic. The lectures will all be on video. You don't have to be in the classroom to watch them, but you do have to watch them and then take the quiz that's associated with them by the due date. In order to attend the first class, you need to be in compliance with the guidelines published on the Protect Purdue website. And in order to attend the labs, you need to be in compliance with that as well. In other words, you need a negative COVID test in order to attend class. Wednesdays from 1 to 3 will be our lab time, and the labs are an integral part of this course. They are very important. I hope that everyone can attend from the very beginning. If you cannot, if you don't have the negative test, you can put off the first lab until the second week. You'll have 2 labs that week, so you'd have to perform a lab on Monday and one on Wednesday. And that's okay, but you need to get your COVID test done so that you can attend class, and of course it needs to be negative in order to attend class. If you have a positive test, get with me and we'll figure out what we can do to get you through the course. Now, every lab on Wednesdays, you need to be in my virtual room. It's my WebEx room. And so you'll see I've got a link here, WebEx meeting room. You need to follow that every lab and have your laptop there open while you're working in the lab, so that if you have questions, you can come over and ask me questions, and I'll be there as well virtually, just waiting to help you. Please take advantage of that. Please ask me questions, because that's why I'm there. I've run this class in person quite a bit, and students always have a lot of questions if they're working well in the class, and that's good. This is a very interactive class, and so it's interesting to try and execute it via distance, or in our case this semester with the virus going around. So let's see. By comparison to your other classes you may have this semester, this one may have a few of the more of the kinks worked out, because I've taught this course via distance for several years now. My primary home location is New Albany, Indiana, and I have a couple of students there this semester. The bulk of my students are actually spread around the state for this course this year, which is an interesting change for me. I like it. In the past, I always tried to go around to every site and meet all the students. Obviously, I'm constrained not to do so this time, so I'd love to meet all of you in person. If some of the restrictions start to be lifted, I will certainly make my way out to each and every site to meet all of you, because I want all of you to learn. I want all of you to know that I care about you as a student, and I want you to enjoy this course. I want you to learn a lot and feel like you've accomplished something. This course draws on several of your other courses, and we apply some very detailed things, and students typically like it by the time they get to the end, at least. So let's start through the course content. The table of contents I don't think is all that useful. I don't recommend following this link. It just brings up everything that's in the list here. You can just go through the list and see what all is available. Let me start at the top, though, with the syllabus. And in the syllabus you can see the fact that this is online Monday 1 to 3 p.m. and then Wednesday is the laboratory. Now, the laboratory will not be online. It'll be at whatever room is assigned to you at your location. My office number is listed here, and I've posted my schedule also. We'll go through that in a moment so that you can tell when I'm available. I will add my cell number in here, but since I am recording this and putting it on YouTube, I thought I'd save my cell until later. So you can just look at the syllabus online and see my cell number. There's no required text. That should save you some money. There is a suggested text, and I'll show it to you here in a minute. But I wouldn't buy it unless I could get it cheap. It's a good book. It's different than most of the mechatronics books out there. It still has most mechatronic books focus on signal processing from sensors. And to me, that's not all there is to mechatronics. There's a lot more to mechatronics than that. I do recommend the book because, like I said, it's one of the better mechatronics books in my opinion, but it's expensive, so I don't require it. In fact, I only reference a couple of chapters out of it anyway. You're probably interested in how you will earn a grade in the class. Here it is. There's homework and laboratory exercises. That's 20% of your grade. But there is a big project usually, and we try to get to a second project. I have succeeded in the past, but not very often. It just depends on how quickly the class advances. But There's one main project that involves an inkjet printer. Basically what we do is we take an inkjet printer, tear it apart, hack it up, and make it so that we control the carriage motion back and forth in a very precise manner. In fact, our goal is to set a glass of water on top of that carriage, move the water back and forth, and the water should not jostle around. It's kind of interesting, the math and the effort that can go into it. And basically we're making a single axis robot actuator is what we're doing. There are 2 exams in the class, a midterm and a final. Each exam is worth 20% of your grade. And the exams just ask you to perform the same sort of tasks that you've learned in the lab. So if you wonder how to prepare for your tests, your exams, make sure you understand the labs. Make sure that you can accomplish all the labs. Make sure you keep up with them, you do them on time, and you ask questions along the way for anything you don't understand. Here's our outcomes, what we're trying to accomplish and what you should be able to do. If the weather's bad, it won't affect us a whole lot except for on lab days. So just look at your local campus schedule modifications. I'll follow those and I'll work with you to make sure you can make up any time. There's also obviously the possibility that someone will get sick and a particular location will be closed down. That is possible. If that happens, again, I will work with you. I'm trying to make sure everyone is performing the labs individually this semester, so that you will all have a set of equipment that you can just take home. If we know, okay, we're in lab, but we're not coming back next week because someone is sick and so they're shutting down the site, at least to students, I'd like you to be able to take your Arduino Uno and the printer and whatever you need to continue working on the project, or the labs, or whatever it is, whatever point in the course we happen to be. Now, one thing about the labs, when we have so many people on WebEx, audio can be very difficult. You end up with feedback, you end up with people talking over each other. One of the things I'm going to do, I'm going to sit in my office for the WebEx classes. And I'm not doing that to avoid the New Albany students, because that's where I'll be. I'm doing it because if I'm down in the lab with the New Albany students, the background noise will affect students at other sites. So if a student asks me a question in Columbus, for example, I'm trying to answer the question, the background noise in the lab can make the conversation difficult. So I will stay in my office even though I'll have students in a room just a few doors down from me, and the reason for that is for audio quality. One thing you may consider doing, last year I had a helper in Anderson, and he bought a head microphone set. It was a wireless system, and it was for gaming. So they're relatively inexpensive, and he loved it. I thought it was so great. He had a mute button on it, and he could walk around the lab and just touch a button and be able to talk to everyone, remotely or wherever. And so I do highly recommend those. Working with the audio on your laptop is just a pain. So I would recommend a set of headphones and microphone that's wireless. I think that would work well. Now, of course, it's possible that the sets will interfere with one another, radio interference, but we'll cross that bridge when we come to it. A lot of times those transmitter-receiver systems have different channels you can select, so we can probably work around that. By the way, it's interesting, we have New Albany students. We have a student who's driving to Anderson from West Lafayette. We've got Anderson students, Richmond, Columbus, and South Bend. South Bend is also a new site for me to teach at, and so welcome to all of you. All of you haven't been through the course yet either, so it's all new to you anyway. Now, I've got a blurb in here about completed tests being temporarily returned to you, but this semester, the way things are, I intend to give the tests online. I expect you to go into my WebEx room for the test. I'll give you the test virtually, and you'll accomplish the test, ask me questions. I expect you to leave your video conferencing system on. And when you're done, you can turn it all in electronically. So obviously you'll have a copy of the test, which is okay. Things are going to be a little different this semester. Let's see. Don't cheat, please. I have caught students cheating in this very course. And if you cheat, I won't say that. I can't promise I won't try to kick you out of school. I might. I haven't in the past. I usually take cheating as a learning experience. I firmly believe that when you cheat, you're only hurting yourself. And I know that sounds trite, but it's really true. So please don't cheat. if you feel like you're getting behind in the course, talk to me, and let's see if we can have some makeup sessions, some time where we can get together, because it's all virtual meeting anyway, except, you being in lab. So we can meet and I can help you understand the course concepts or work out a problem with your programs or whatever the need be. I'm glad to help. All right, if you want to connect with me via social media, I will accept LinkedIn requests now if you want, but Facebook friend requests I don't accept until after you've graduated. I try to keep professional and personal life a little bit separate. There's some sort of boilerplate wording for COVID. Please do read through that, but you've probably seen it already in another course, so I'm not going to go through this in detail. All right, the way the course is laid out then, there's a Start Here section, and there's many different things here. Read through this, please, but the most important thing I think is that you shouldn't try to complete this course on your cell phone. That won't work. You need a laptop, you need a computer, you need some system where you can submit things easily. There is an app for Brightspace. I do recommend it, but it's not something that allows you to use Brightspace just as well as if you had a laptop. So you need a good, strong internet connection so that you can watch the videos and you can conference real time if necessary. But please don't try to complete this course with your phone. There are a lot of resources that Purdue has for helping students succeed in their classes, and so you see several links here. Do peruse those and use them as you need. There's also accessibility information, so if you need extra time on tests and so forth. I know I've already got one student who has information that's been sent to me about extra time on tests, things like that. That's fine, that's good. Just make sure that I have a copy of it if you don't know that it's automatically been sent to me. I don't know if all will automatically be sent to me or not. This is the first time I've ever seen them sent to me via the university. There are a lot of university policies. Go through these, if you will, please. And I'm not going to go through them in detail right now because you can go through those on your own as needed. Course information. So let's get into a little more meat of the course. Shouldn't have a syllabus there. It's up here. I need to delete that link. I forgot it. But my schedule is the first thing I want you to see. And you can click on this yourself. I'm viewing this course as a learner right now. The times that I have listed here are not the only times I'm available. In fact, last semester, when COVID hit and we all went home and worked from home, I was on WebEx in my virtual room with students until 11 o'clock at night. And I don't mind. I really like mechanical engineering technology, and I really enjoy this particular class. I'm glad to meet with you and help you however I can, so please take advantage of that. Now, there are some times that I cannot meet with you. My schedule with my daughter is a little bit strange. When I pick her up varies a bit, so I've sort of blocked out the time from 3:30 to 4:30 or so where I won't be available because I'll likely be picking up my daughter. Also, I thought it'd be nice to kind of have a break in the day somewhere along the line. But if you want to meet with me before 9:30, that's okay. If you want to meet with me after 5, that's okay too. I will be in my virtual room, though, during most of the times that you see, either that are class times or that are shaded and say arrange hours as needed. And so you're welcome to just come into the virtual room. Now, if there's something going on, we're sort of having class and you walk in virtually and you see that we're busy, I would ask you to come back later, unless it's something you can ask quickly if we're not busy, But do take advantage of this. I'm going to try to leave my virtual room on most of the time. It may be on my phone because I may be video recording with my laptop. But please let me help you. Whatever you need, let me help you. What else here? Oh yes, on Fridays I probably will not be available after 3:30 or so, though. You probably won't either. You'll probably want to get your weekend started and either catch up in your courses or have some fun. So if you really need me to meet with you on Fridays, I'll be glad to. I have come into my campus location in New Albany on the weekend, a Sunday even, to let students in the building and work with them and do whatever's needed. So feel free to ask me questions and try to get with me at pretty much any time. Here's the text that I recommend. As I said, it is not required. I've got a paperback ISBN number here, and if I remember right, the hardback is about $200, the paperback's about $34, $35. Since I don't require it, I don't require that you purchase it, obviously. It is a good book, though, and if this is a topic you really like, I would recommend that you kind of use this as a starting point for further investigation into mechatronics. Now, I am going to turn on some course learning modules. In fact, I've got one scheduled to turn on here at 12 o'clock today, I believe. But the way I organize this course is I have a lot of course learning modules, and the videos are already set up there, the assignments for the labs are set up there, and what you do is as you see a new course module, you just go into it and you watch the videos that are there. There are some optional videos, often it's a playlist of optional videos and a playlist of required videos, and then you take the quiz associated with that lecture material. And the purpose of the quiz is just to make sure that you're watching the videos on time and you're participating in the class, because what I've found in the past, if I don't give students a cutoff time for watching the videos and answering some questions about those videos, what I find is that they put it off. They think, well, I'll watch it a couple hours before the laboratory on Wednesday, and then they don't get around to it. They get to the lab and they really don't know what they're doing. That doesn't work well for you or for me. I really need you to watch the videos, and I know all of you have the full intention right now of watching them, but things happen. Other things come up that seem more important, and if there's no hard deadline, you may push back watching videos, and I don't want you to do that. So there will be learning modules that appear here. Go through those as I post them, because essentially the Mondays are the days where you learn new topics, and then the Wednesdays, the labs, are where you apply those topics. I've got some past laboratory videos, and a lot of these are from when I was first teaching the course and we were using the basic stamp as our microcontroller rather than the Arduino. But you can kind of see the sorts of things we were doing. Some of these are my videos, some of the student videos, and we do similar things in the class now. I just, for whatever reason, have not taken the time to make videos of, or collect the videos together of recent student work. Past student projects. Here is an example of your project where other students have succeeded. You can see the printer carcass, you can see the container of water here, and the Arduino that's controlling them. But students have succeeded in the challenge of making the glass move back and forth without it moving really slow, but also without it jostling as much as it would with a simpler velocity profile. When I first taught the course, I wanted to get the students interested in the class, so I bought a pinball machine and brought it into the classroom. Not for us to play pinball, but for us to figure out some project around the pinball machine. What we decided to do was make the pinball machine play itself, and the embarrassing part is the first time this pinball machine played itself, it beat my high score. So we succeeded, and it was a fun project. The students thought it would be fun. They ended up not working on it very hard. The other things took priority because it was just open lab and project time. And so toward the end, I told them that they'd all have to write a long paper about what they had contributed to the project, so that kicked them into gear. And the day it was due, they were still working on it feverishly when the deadline came. And I went into the lab and saw that they had, worked on it fairly hard, and they were really close, and I told them they didn't really have to write the paper anymore because I was satisfied with the work they had given me. Well, they became intrinsically motivated. They stayed until midnight that night working on this darn machine, made it work, made this video and sent it to me at about midnight or so. It was really neat. I was really glad to see them accomplish the challenge. So remember, you can accomplish the challenges that I'm giving you. They're not impossible. Students in the past have succeeded, and you guys are just as good as they were. I know because, well, I don't know obviously, but from past experience with students throughout the class, students have always been capable of doing it. Whether or not they actually accomplish it depends more on their work ethic and how much effort they put into the class. And things happen sometimes, things happen in your life where you can't get through the class, but you can do it is all I'm really saying. Now, if we get through the printer project and we have a little bit of time, I want to include another project. That's why I said projects in my syllabus. Here are some of my ideas. I don't know if you guys have ever seen the arcade game called Ice Cold Beer. It's not a video arcade or a pinball machine. It's really interesting. You've got two joysticks and you can move both of them up and down on either side. They don't go left and right, just up and down. And they control two sides of a bar where you can move one joystick and the right side goes up, for example, the left joystick controls the left side. And there's a ball that rides on that bar. And what you're trying to do is move the bar up to control the ball and get the ball into particular target holes. And it gets harder and harder as you accomplish one hole after another, because you start at the bottom every time and you have to get past all of the holes in the board that you've already hit or that you don't want to hit. It's an interesting game. I really like electromechanical games like that. So that's something that could be some type of project. There's another system called Auto Tracker. It makes a video camera follow a lecturer. So these are things that are actually available, but we could build our own. That could be interesting. We have some Pixie Cams that I can distribute to you guys, and Pixie Cams are just these little cameras that, well, look it up. You can find out more about them. They're basic, very basic, intelligent cameras, if you will, basic vision systems, although they're not near as complicated or capable as industrial vision systems. Another interesting thing is this self-balancing stick. Now, I've actually had what these are called reaction wheels. I've had these reaction wheels machined out, and I bought the motors and things so that we could build these. We didn't get around to it in the past class. But the way this thing works is basically a stick, and it's got an accelerometer at the top, and as it starts to move, the motion is sensed and the wheels turn automatically in order to balance it out. It's a really neat thing, so watch this when you get a chance. And there's a lot of resources available for this project. We did get to the point one time when I taught the class of building a self-balancing robot, and that was really interesting. We built something kind of like what you see here, and it did balance. It looked like it was going to fall over all the time because it was moving back and forth constantly. It didn't balance quite as nicely as what you see in these videos, but we did succeed. It didn't fall over until we shut it off, so that was fun. Here's another balancing robot. Here's what made me interested in balancing robots. I went to a show, I think it was the, where was that? It must not have been IMTS. I don't remember where it was, but I saw this robot sitting there, and it had a screen display and an expression on its face, and it was just interesting because it acted like it would fall asleep standing up, and it was just cute, and I enjoyed it, so I thought, yeah, that'd be neat, and found that other people had done it, so we did it as well. We could do something artistic with spinning LED lights. That can certainly be mechatronic if you're interested. One of the things I would like to do is I would really like to be able to see more detail of the International Space Station as it traverses overhead. There are already projects where you can build an International Space Station pointer, and it's just an Arduino-based device that points at wherever the International Space Station is relative to your position. It even points through the Earth to the other side of the Earth when the ISS is on the other side. If we took something like that and we allowed that, instead of pointing just a pointer, if it pointed a telescope in that general direction, or a Pixie Cam with a low power telescope, maybe the Pixie Cam could tell us where the brightest dot is in its view, which would probably be the ISS, and then we could focus a higher power telescope at that particular point. I think that would be really neat. I would love to get to the point where I could actually view the space station traversing overhead, automatically track it, and just see it on a screen, see its solar panel sails and all those sorts of things. I think that would be really neat. And so this is just a video about building a relatively inexpensive telescope that is relatively high power. Now, I always like for students to have input on projects. So if we get to the point where we can do something besides the inkjet printer, a project beyond that, then let's talk about it at that point. Any ideas you have, I would love to hear. So please, think of something that would be mechatronic, and you'll understand the definition of that after you watch the lecture videos. But if there's something you want to work on, something you want to do, I would be interested. So keep your creative juices flowing and your mind open, okay? And we'll hopefully enjoy this class, and hopefully you'll learn a lot.